Bonsuelo athletes, here it is. This is kind of like the gist of the rest of the chapter, all right? Now, I'm going to show you something real quickly. You don't need to write it down, just watch. I posed this to you back a while ago. Is 7, well, actually, let me use I think the exact same thing that I gave you. I'm not going to make up a new one. Is 2, don't write this down, a factor of 7? And at the time we said no. Why not? Because if you divide 2 into 7, it doesn't divide in evenly. And how do we know it doesn't divide in evenly? Because there's a remainder. Okay? So the divisor is a factor of the dividend only if there's no remainder. So for instance here, I could change this problem to the following. Is 2 a factor of 6? And in this case, the answer would be yes. Why? Because there's no remainder. Okay? I'm telling you, the rest of the chapter all depends on that. And I'm going to tell you a lot of other stuff too, but when it comes down to it, what do you do if you want to know if something's a factor? Well, first of all, you try and factor it by inspection. That's what I just reviewed on the last video. But what if you can't factor by inspection and its degree is 3 or greater, okay? Well, if its degree is 2, you don't do this. If degree is 2, then use the quadratic formula, okay? So this is kind of where we're headed. Okay? To factor. And you don't need to write this down. I'm just kind of giving you a heads up. This is where we're headed. What do you try and do first? Factor by inspection. Just by looking at it. What's that? Greatest common factor, difference of 2 scores of a trinomial, perfect cubes. That's what I'm calling factor by inspection. That's what I referred to it in the last video. Okay, if you can't do that, then you've got 2 possibilities. First one is if it's quadratic, in other words, its degree is 2, use the quadratic formula. Now, of course, you can complete the square also, but most people prefer the quadratic formula. But B, if the degree is greater than or equal to 3, then what you do is you divide until the remainder is 0. Okay? So let me point out to you something. And by the way, just so you know, by quadratic, of course, I mean that its degree is equal to 2. Okay. If you've got degree 3 or greater, what do? You divide. Then the next problem, what do? Divide. Then you divide. Then you divide. Then you divide. And after that, you divide, and then you divide. And after dividing, you divide some more. I'll give you a hint. If you're not dividing, you're not doing what you should be doing. Okay? So you try and factor by inspection. Sorry, not the degree is 0. I don't know why that bell keeps ringing. The degree is 2. Okay, you use the quadratic formula. If you're not dividing and its degree is 3 or greater, you're not doing what you should be doing, okay? And that can be long division or it can be synthetic division. Of course, if you can do synthetic division, it'll be easier. All right, so let's take a look at this. This is called the factor theorem, and it basically just says what I just said. If a polynomial is divided by d of x, so this thing is the divisor, then the divisor is a factor of the dividend only if the remainder is 0. Okay? So, let's take a look at a couple of examples. Is x plus 3 a factor of p of x? Okay? Now, how do we figure that out? Just divide. Okay? Now, since it's x plus 3, I'm going to use synthetic division. Just easier. So we've got negative 3 in the box, and we've got negative 2, negative 8. Remember, you got a cube, a square. You have to put in the missing x coefficient and then 5. Okay. So we've got, and this you should be able to do quickly by this point. So we've got negative 2, 6, negative 2, 6, 6, negative 18, and negative 13. So is x plus 3 a factor of p of x? No. Why? Because it's got a remainder that's not 0. In other words, it doesn't divide in evenly. It's that simple. Does it divide in evenly? If it divides in evenly, it's not going to have remainder. Okay, let's see. Is negative 3 a 0 of p of x equal that? Well, you know what? This is the exact same question, just worded differently. X plus 3 is a factor. Negative 3 would be the 0. I don't know why this bell keeps ringing. Anyway, so what do? You just do the exact same thing. Okay? I want to point out something. Saying is x plus 3 a factor is the same thing as saying is negative 3 a 0. Okay? They're saying the exact same thing. Notice I'm putting negative 3 in the box. I'm not putting 3 in the box because the 0 has the opposite sign of x plus 3. Okay? X plus 3 would be the same thing as a factor of x plus 3, as a factor of x plus 3. So the negative 3 goes in the box. Okay, so we have negative 2, 6. It's the exact same problem. It's just a different way of wording the exact same thing. So again, we have a remainder, so the answer is no. Okay. Is x minus 2 a factor of f of x? Well, let's see. Okay, 2 is going to go in the box. And we've got 1, 4, negative 8, and negative 8. Okay, so let's see what happens. So we've got 1 times 2, 6 times 2, 4 times 2, and 0. So yes, x minus 2 is a factor of f of x. Why? Because there's no remainder. X minus 2 divides in evenly. Okay? How about is 2 a 0 of f of x? You know what? It's the exact same question, right? Make sure you understand factors and zeros. Remember, just a quick review. I'm going to write something down. If you have this, I'm making up these numbers, by the way. This is not this problem. Okay? X would be negative 9 and 5. These are the factors. These are the zeros. All right? So the zero is, the potential zero is the thing you're putting in the box. Okay? So be very careful here. Saying that 2 is a 0 is the exact same thing as saying x minus 2 is a factor. All right? So how would you do this? Well, hopefully you wouldn't need me to show you because I just showed you. You put 2 in the box, and you have 1, 4, negative 8, and 8. So we have 1, 2, 6, 12, 4, 8, and 0. So again, yes, 2 is a 0. Asking is x minus 2 a factor is the same thing as asking is 2 a 0. All right? All right, so let's take a look at this. Factor that thing if 2 is one of the zeros. Now, I'm telling you 2 is one of the zeros. Okay, so how do you factor it? Well, look to factor by inspection. Now, I'm going to say this right now. This does factor by inspection. Okay? So I'm going to show you the way I'd really do this. Okay? And you might just want to listen for the time being, but okay, we're going to group it. That's x squared times x minus 2. Pull out a 9, and that's x minus 2. So we get x minus 2 times x squared minus 9. And then that factors into x minus 2 times x minus 3 times x plus 3. And I didn't ask you to solve this. I didn't ask you to find the zeros. I just said factor. So we're done. Now, what's another way of doing this, though? Okay, but that's the easiest way to do it. All right, but what if you couldn't do this by factoring by inspection, which you can, but I'm just going to show you what to do. What do? You divide. So you'd put 2 in the box, and you'd say 1. You don't have to do both of these, obviously. You just do one or the other. Okay, so we got 1, 2, 0, 0, negative 9, negative 18, and 0. Now, here's the important part. Okay? The factors are the divisor, and the divisor is x minus 2. 2 is not the divisor. Remember, this is a factor. If 2 is the 0, the factor is x minus 2. That's the divisor times the quotient. Now, I've said this to you before, but I just want to kind of reiterate it again. It's very important. Okay? So I'm going to write something over here on the side. It's like saying this. Well, if I divide 2 into, I don't know, 6. Okay, what does 6 factor into? The divisor, which is 2, times the quotient, which is 3. It's that simple. Just divisor times quotient. Okay? So what I'm telling you to do is this. Factor, and then write the divisor times the quotient. Next problem, what do? If you can't factor by inspection, divide and write the divisor times the quotient. Divide and write the divisor times the quotient. Then you divide and write the divisor times the quotient. Okay, so let me get rid of these words here because I need the space. And now we just continue factoring. So we got x minus 2, and then this factors into x minus 3 times x plus 3. Get the same answer. Okay, now something obviously a little more complicated. Factor f of x if 1/2 and negative 5/3 are zeros. Okay, here we go. What do? Well, you can't factor that by inspection. Just by looking at it, there's no greatest common factor, no difference, 2 squares are a trinomial, no perfect cubes. It's not quadratic, so we can't use the quadratic formula. So what do? Divide and then write the divisor times the quotient. Okay, does it matter? Now we have 2 things to divide here. We have the 1/2 and the negative 5/3. Does it matter which one's first? No, so I'll go for what looks like the easier number, 1/2. Okay, so we have 6, 7, 55, 70, and negative 50. Okay, so we should get a remainder of 0, because I've told you these things are zeros. So that's 6, 3, 10, 5, 60, 30, 100, 50, and 0. Good deal. Now what do we write? Divisor times quotient. So what's the divisor? The divisor is x minus 1/2. Remember, this is the 0. And the factor is x minus the 0. And then, so that's divisor times quotient. 6x cubed plus 10x squared plus 60x plus 100. Okay, now let's continue. Now, I could divide the negative 5/3, but you know what? Is there a greatest common factor here? Yeah, I can pull out a 2. So, whoa, what happened there? That was weird. Okay, so I'm going to pull out the 2. And I'm going to stick the 2 in front of the whole thing. It doesn't matter. You can stick the 2 in there, or you can stick the 2 in there. It doesn't matter because the order of factors doesn't matter. So I'll just write it as it is. X minus a half, and then I'm going to take out the 2, and that leaves me with 3x cubed plus 5x squared plus 15x plus 50. Now, at this point, you can factor this by inspection. I'm going to do it real quickly, but what if you don't see that you can factor it by inspection? I'll go back and do it, by dividing. Okay, so how would this factor? This would factor, and you might not want to write this down yet. I'm going to take this 2 and put it in front. Okay, now, I'm going to take out the x, that's supposed to be an x cubed. I'm going to take out the x squared, which gives us 3x plus 5. And on the second one, I'm going to take out the 5, which gives us 3x. What did I do weird here? Okay, so we got 2, 2, 2, and 2. So we take out the x squared, we get 3x plus 5. And we take out the 5, get 3x. Gotta admit, I'm kind of stumped here for a second. Okay, so we got that. That's good. So divide by 2, 3. Divide by 2, 5. Divide by 2. Oh, sorry, that should be 30. I apologize. This should be 30 right here. Okay. So that means that I can take out a 10. And that gives us 3x plus 5. Okay. Now, let's take out the 3x plus 5. That's our greatest common factor. And that gives us x squared plus 10. And now I can factor the x squared plus 10. And that would be what times what gives us x squared, x times x. What times what gives us plus 10? It'd be plus square root of 10i and minus square root of 10i. Okay? So that's it completely factored. Now, I've got some space here, so I think I'm going to leave that as it is. Okay? That's how you do it if you factored by inspection after the initial division. But let's say at this point right here, you don't see that you can do anything. Well, it'd be good if you saw you could take out the 2 at least. But if not, you could still end up getting the answer. But so what do? I know that negative 5/3 is another 0. So from this point forward, okay, I'm going to divide the negative 5/3 into the 3, 5, 30, and 50. Okay, so we drop down the 3, multiply, get 0, multiply, get 30, multiply, and then get 0. Good. So what would that leave us with? F of x equals. Now, we have to bring down the factors we've already got. And what factors do we already have? We already have x minus, and I'm taking it from this line right here, x minus a half, 2, and now, what I was factoring was 3x cubed plus 5x squared plus 30x plus 50. What are the factors for that? Divisor times quotient. Well, what's the divisor? X plus 5/3. What's the quotient? 3x squared plus 30. So this I got from the first divisor times quotient. This I got from the second divisor times quotient. And again, that's if I don't see this. So I'm kind of like forgetting that. That's a fine way to do it. But if you don't see it, you can always do it by dividing. Okay? Now what would happen? Well, I'd have I'm going to put the 2 in front, the x minus a half, the x plus 5/3. And now I'm going to take a 3 out of this, and we get x squared plus 10. Now, I'm going to combine the 2 and the 3 to get 6. X minus a half, x plus 5/3. And then I'm going to factor the x squared plus 10. So it's x minus square root of 10 I and x plus square root of 10I, which is the same answer I got up above. And now you're looking at it and saying, well, it doesn't look the same. Because in the way we did it before when we factored by inspection, we had that 3x plus 5, and the leading coefficient was only 2. Well, sort of. See, in the second way I've done it, I took the 3 that I factored out, and I stuck it with the 2, giving me 6. I could have given it to the x plus 5/3, which would give me 3x plus 5. So this bottom one here is really the better answer. But this one that I got up here, that'd be fine too. Okay? So both ways, you're going to have to start by dividing. And you get this. Let me get rid of some of these dots and X's and stuff. Okay, no matter which way you do this, you're going to get to that point. And then at that point, you either have the choice of either doing it this way or doing it this way. And both answers are correct. All right? So, both, no matter which way you do it, you got to get to that point. And then either factor it by inspection, which I did on the top, or continue factoring by dividing, which I did on the bottom. One or the other, you don't do both, take your pick. Okay? But basically, what is it? You divide and then write divisor times the quotient. Okay, let's take a look at this. I'm going to factor this thing if 2 is a double zero. Remember what it's a double zero? It's like multiplicity 2. That's what it means. In other words, it's a zero twice. Okay, so what do? Well, I can't factor that by g of x by inspection, so I'm going to divide. Okay, so we have 1, negative 15, 16, and 4. Okay, so we have 1, 2, 3, 6, negative 9, negative 18, negative 2, negative 4, and 0. So what do we write? Divisor, immediately, divisor times quotient. And by the way, don't do a quotient times divisor, okay? You'll not that it'd be wrong, but you'll get messed up. Okay, so what's the divisor? X minus 2. And what's the quotient? X cubed plus 3x squared minus 9x minus 2. Okay, good. Now, Can I factor this by inspection? No, I can't. So this thing, we're going to continue factoring, but how are we going to do it? By dividing. Again, just divide and write divisor times quotient. Because I've said it's 2 is a 0 twice. Well, we've only used it once, so let's do it a second time. But here, your dividend is now the thing that I've underlined. So we have 1, 2, 5, 10, 1, 2, and 0. So now what do we have? Divisor times quotient. But you got to be careful here. Okay? Because we have to carry down this first factor, x minus 2. Then we write the second factor is now the divisor, and then the quotient. So this comes from the first division. That's the divisor of the first division problem. This is the divisor of the second division problem. And then this is the final quotient that we end up with. Now, at this point, what do? Well, it's not factor. It's not divide and write divisor times quotient. Why not? Because it's quadratic. Okay? So what do we do if it's, because this doesn't, if this thing factored by just looking at it, that's what we do, but it doesn't. So remember, what the subject here is degree 3 and greater. That doesn't factor just by looking at it. Well, this is not degree 3 or greater, so what we're going to do is just use the quadratic formula. So we have -5 plus and minus. Remember, this is two things. B squared, which is 25, minus 4 times 1 times 1 all over 2 times 1. Now, don't forget, that is not one number, that's two numbers. It's -5 plus square root of 21 all over 2, and -5 minus square root of 21 all over 2. And each one of those needs its own factor. So what do we have? We have g of x equals that first x minus 2, the second x minus 2. Now, how do you write a factor from the 0, right? These things are zeros. Okay, I'm going to write some stuff on here. Don't write it. If 5 is the 0, what's the factor? X minus 5. If -13 is the 0, what's the factor? X plus 13, or x minus a -13. If dog is the 0, what's the factor? X minus dog. No matter what the factor, no matter what the 0 is, you can find its factor by taking x minus the 0. Okay? So what do? We just write x minus the 0. So we take x minus, and what's the first 0? -5 plus square root of 21 all over 2. And then the next factor is x minus -5 minus square root of 21 all over 2. And I kind of showed you this before when we were factoring perfect cubes, but I just kind of showed it to you real quickly and then didn't finish the problem off because it wasn't appropriate at that time. Okay, those are the factors. It says factor it, okay? Now, what are the zeros? The zeros are 2, which is a double 0, multiplicity 2, -5 plus square root of 21 over 2, and -5 minus square root of 21 over 2. Those are the zeros. Factors are what you see written here. Okay, that's it. Again, what's the main thing we're talking about here? The factor theorem. And what's the factor theorem? It's this. You divide until the remainder is 0. Okay? Now, on these first problems, all I was asking you is yes or no, is that thing a factor or is that thing a 0? Okay, as we got down here, I was actually asking you to factor it. Not just yes or no, but I said this thing's a 0 or this thing's a factor. Now factor it. Okay? So, this last problem is a pretty good summary of just about everything we're going to be doing for the rest of this chapter. All right. Till next time, have a good day, mathletes. Bye-bye.